Good morning everyone. My name is Tanmay Vaja and I am studying Diploma Semester 3 Instrumentation and Control. The topic of my presentation is flapper nozzle system. The system is basic element of pneumatic instrumentation. It converts mechanical displacement into changes in air pressure which can then be used for measurement and control. Slide number 2. Pneumatic control elements and definition. A pneumatic control element uses compressed air to control machinery and industrial processes. This makes it suitable for environment where electrical devices may be unsafe, such as explosive or hazardous areas. The flapper nozzle system is popular because of its simplicity and reliability. It is used in transmitters, controllers, and pneumatic relays to regular process variable without electronics. Basic principle. This basic principle of flapper nozzle system is conversion of mechanical displacement into air pressure changes. When the flapper moves closer to the nozzle, the air gap reduces. As the air gap decreases, the back pressure increases. When the flapper moves away, the pressure drops. This change in pressure becomes the output of the pneumatic device and it is used for control and measurement. Slide 4. Components. The diagram shown the main parts of flapper nozzle system. Nozzle, it directly compressed air in a narrow path. Flapper, it controls the gap at the nozzle outlet to vary pressure. Supply air, this is the source of pneumatic power that feeds the system. Restrictor or orifice, this it limits the airflow to stabilize the system and create differential pressure. Output pressure line. This line carries the regulated output pressure to transmitters, pointers, or controllers. Slide number 5. Working mechanism. The flapper nozzle is a simple if the gap between the flapper and nozzle increases, air escapes freely and back pressure decreases. If the gap decreases, air escapes slowly and back pressure increases. A typical output pressure ranges from pneumatic control is 3 to 15 psi. These pressure ranges can then be used to operate transmitters to control valves with high accuracy. Slide 6. Work advantages. The flapper nozzle system has several benefits. Simplicity. The design is straightforward and requires very few parts. Sensitivity. It responds to very small mechanical changes, making it suitable for a feedback system. Reliability. There is no electrical spark risk, so it is safe in explosive environments. Safety. Since it is used only air, it avoids electrical hazards such in short circuits or fire. Limitations. The system does have limitation. It is sensitive to dust and particulate matter. Because any blockage affects the air, it requires a clean and dry air supply, otherwise moisture or dirt will reduce accuracy. Compared to electronic systems, its accuracy is very low, especially when fast response or very fine control is required. Slide 8. Industrial application. Flapper nozzle systems are used in multiple industrial applications. They are commonly seen in process transmitters for pressure monitoring. They are key components of well positioners, which ensure accurate well positioning. They are also used in pneumatic controllers to provide stable automation without electronics. This wide industrial usage shows the system's durability and reliability. Slide number 9. Summary of working principle. To summarize, the flapper nozzle system converts mechanical movement into pressure signal. When the flapper position changes, the back pressure at the nozzle changes. The pressure becomes the control output for the pneumatic device. Its design is robust and suitable for heavy industrial environments. Slide number 10. Continued relevance. Even today, this system remains highly relevant. It's cost effective, easy to maintain, and does not require advanced electronics. Industries still use it in applications where reliability is more important than digital precision. The system continues to deliver efficient performance while keeping operational costs low.